Today we will discuss about elementary transformations. In previous lecture we discussed about conformable mapping. If you have no idea about conformable mapping, then you can see the link which is given in description. In elementary transformation we discuss about translation, rotation and magnification or stretch. When if our plane is Z plane, then by applying the translation property, it will map in another plane which is called W plane or sigma plane. Similarly, rotation and magnification. If we discuss four properties, translation, rotation, magnification and inversion, then it will become a bilinear transformation. In this today topic, we discuss about just elementary transformations. If we have a Z graph like this in Z plane, the point A, B, C and D is 0, 1 and along y-axis is this. If we apply the translation property, which is W is equal to Z plus alpha, where alpha is a complex number. Let's take an example. W is equal to 2 plus iota, where 2 is Z and iota is a complex number which is equal to alpha. When we add any complex number in Z, then this plane will map into sigma plane and it will move from this point to this point. How? Because we have 2 plus iota and our point along x-axis is 2 and along y-axis is iota, and iota coefficient is 1, so that's why our A point is 2, 1. When we add alpha with Z, then this graph will move to 1 point. So this point is also moved to 1 point, C will also move to 1 point and D will also move towards 1 points. In translation, our graph is in this form, so it will map into Z plane as it is in this form. Basically, like other mappings, in some mappings, if our graph in Z plane is linear form, rectangle, triangle or any other form, then in another form it maps in another way. Line maps in the form of circle map in the form of line. But in transformation, our graph is mapped as it is. Just it move points 2 and 1. Next, we will discuss about rotation transformation. For rotation transformation, our condition is W is equal to A iota alpha Z. Our graph will transform according this condition, means Z time e raised to power iota alpha. Rotation means our graph just rotate at some angle like this. It is anti-clockwise. Points will not change, just rotation means just our Z graph rotate at this angle. Now further, stretch or magnification transformation. Z plane is like this. For magnification or stretch transformation, the condition is W is equal to alpha Z. Alpha is a real number. We can see that B point is at 1. If we take alpha is equal to 1.5, then our graph move 1 to 1.5 and it will also move along this side. So if we take, basically alpha is a scaling vector. If we put alpha greater than 1, then our graph will stretch outward. If we put alpha is equal to less than 1, then our graph will stretch inwards. Next, if we discuss about bilinear transformation, in which we will discuss about inversion Just here we see its graph. Further example we will discuss in next lecture. What is the condition for inversion? W is equal to 1 over z. We will take the inverse of z plane. The inverse plane graph is not simple, so just we will try to draw it. Let's suppose we have any 1 over z is equal to 2 plus iota. Then how can we find out the complex numbers? If we have a complex number in denominator, then we will factorize it. By changing the sign of iota, we will multiply it and divide it. Then 1 minus 2 iota multiplied by 1 and 2 plus iota into, we have an example 1 over 1 plus 2 iota. In complex number, we multiply and divide by changing the sign of iota. 1 minus 2 iota over 1 minus 2 iota. 1 minus 2 iota into 1 minus 2 iota. 1 plus 2 iota into 1 minus 2 iota will become 1 plus 4. When we separate real and imaginary part, it will become 1 over 5 minus 2 over 5 iota. When we plot this function graph in w plane, then it will become like this. Our A point is this and B point is this, and our C point from this point to this, and our C to D point moves from this point to this point. Just there are 4 conditions to rotate our Z plane graph into W plane graph: translation, rotation, magnification and inversion. For translation, W is equal to Z plus alpha. For rotation, W is equal to E iota alpha Z. And for magnification or subtract, W is equal to alpha Z. And for inversion mapping, W is equal to 1 over Z.